Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammadur Rasulullahi Kareem. This problem is related to chapter partial differentiation of differential calculus. If v is equal to x²+y²+z² whole power m by 2, then find the value of m where m does not equal to 0, which will make del to v over del x² plus del to v over del y² plus del to v over del x² is equal to 0. We are given the value of v, which is see here, v is a function of x, y and z, which is equal to v is equal to x²+y²+z² whole power m by 2. I give its equation number 1, and for putting it in this equation we have to find the value of second derivative of v with respect to x, y and z. First we have to find this value, so we differentiate equation 1 partially with respect to x. So on differentiating equation 1, we get del v over del x on the left hand side, and on right hand side we differentiate considering this value is x and applying formula del d over dx x to the power n is equal to n x to the power n minus 1. After applying this formula we get, because I consider it as x to the power m by 2, on applying this formula we get m by 2 x to the power n minus 1 m by 2 minus 1. What we see that it is not x, so by chain rule we must differentiate partially with respect to x. This we consider as x previously. M by 2 x²+y²+z² whole power m by 2 minus 1, differentiated with respect to x partially. On differentiating this term we get, according to this formula, 2x to the power 2 minus 1. For partial differentiation with respect to x, y and z constant, so differentiation of y square and z square is equal to 0. M by 2, I write this value which is equal to 2x to the power 1, which is equal to 2x. I write it here because multiplication is commutative, so we can write 2x previous. We can cancel out this 2, we get now m, which is constant. What here is x variable, and this quantity is also variable with respect to x and y. Now we have to find second derivative of v with respect to x partially. So again differentiating with respect to x, we get del to v over del x square. On differentiating with respect to x, on right hand side m is constant, what we have to differentiate this quantity which is function of 2 function, multiplication of 2 function. We should consider x as first function and this is second function, and applying formula we get first function as it differentiation, partial differentiation of second function x² plus y² plus z² whole power m by 2 minus 1 plus second function as it x² plus y² plus z² whole power m by 2 minus 1, and differentiation of first del over del x. First function is x. So we get del 2v over del x square. Now we should simplify this value del 2v over del x so that on next step we will not face any difficulty. Write x as and differentiate like we on the previously I do here according to this formula. So differentiate this value, but here this power is m by 2 minus 1, so we get write x firstly and applying formula m by 2 minus 1 and x² plus y² plus z² power m by 2 minus 1 is also there, but after applying formula we should subtract minus 1. What the same logic as previously I say, we should differentiate x² plus y² plus z² partially with respect to x according to chain rule. Now we go to next term which is plus positive. I write this value and differentiation of x with respect to x equal to 1. So I write plus x² plus y² plus z² whole power m by 2 minus 1, and differentiation of x with respect to x is equal to 1, close bracket. We can solve this value m by 2 minus 1 and x² plus y² plus z² and m by 2 minus 1 equal to minus 2. Differentiate this value. Differentiation of x² is equal to 2x with respect to x partially, and for x, y and z constant, so differentiation of these quantities is equal to 0. Plus write this without any change, x² plus y² plus z² whole power m by 2 minus 1. We can take 2 as LCM in this bracket. These are two fractions, and also we can take out this factor as common out from this bracket, so we can write it as x²+y²+z² whole power m/2 minus 2. We can take out only that power which is lower. We know that m/2 minus 2 is less than this value y1, so I take this value from outside bracket. We get x, and I say 1 and 2 LCM equal to 2. 1 multiplied to m we get m, 2 multiplied to 1 equal to 2. We take out whole from this bracket only. We have 2x here, plus what I take out only m/2 minus 1 power 2 power, so 1 power is remain here, so I write only x²+y²+z². We can cancel out 2, and x into x multiply it becomes x². Next term m x²+y²+z² m/2 minus 2, and we write m minus 2 first, and then x into x² plus x²+y²+z². This is value of del2 v over del x². I write it as equation number 2. Since v is symmetrical about variables x, y and z, symmetrical about x and y, so on differentiating v with respect to y and z, we get similar result, so there is no need to find out again del2 v over del y² and del2 v over del v² for sake of time and lever. So we can write similarly del2 v over del x². It is not necessary in examination to find out this value. It is enough to find out this value, and you can write similarly, and you can write according as m x²+y²+z² m/2 minus 2. It is common to all. Only role of x² change to y, so we write y in place of x in this equation 2. We get m minus 2 and write y². What this value again symmetrical about x, y, z, so we can write as y² and x², but addition is commutative, so and also associative, so we can write x² as here and y² as here plus z². Therefore there is no change because it is symmetrical, both x and y, x and y and z also. So we obtain equation number 3, and also we can write similarly del2 v over del z². Only role of y change to z, y writing here z². All factors and terms are same, so we write without any change, but only this term y square replaced by z square, x square plus y square plus z square. This is equation number 4. What we are given that this value is equal to 0. So we use this value to find out the value of m by putting these values from equation number 2, 3 and 4, and we get the equation which will contain only m and one unknown, so we can easily find the value of n. So we go to we can write this. We are given that also del to v over del x square plus del to v over del y square plus del to v over del z square is equal to 0. So we have already find these value in equation 2 and 3 and 4. So put these values from equation number 2, 3, 4. Therefore we can write value of this from equation number 2. This value is small m x square plus y square plus z square, or you can add these values add it by column wise by without putting these values. You can also add directly after writing this equation, because these terms, on writing this term, it is very lengthy to write, so I not write it here, and if you want to, you can write, but I not write here because in these equations these values are common, so I take out from brackets and write here as m x square by square z square whole power m by 2 minus 2, and after it we also add these terms in brackets. What in these terms also m minus 2 is common, so we take m minus 2 is common, we get x square plus y square plus z square. If any difficulty in this step, you can ask me. I will provide a video and take link in this video description. X square plus y square plus z square, on taking common m minus 2 common out for m minus 2 from these terms, because on taking common out this we have to add these terms, so we add these terms and take out m minus 2 as common, and after it these terms which is like terms, we consider one quantity which is equal in 3 terms, 1 times, so this becomes 3 times, so I write it 3 times x square plus y square plus z square. This value is equal to this. On right hand side I write which is equal to 0, and also we can take out this bracket. We get m x square plus y square plus z square m by 2 minus 2, and I take out this bracket x square plus y square plus z square, then we get m minus 2 plus 3 equal to 0. This bracket have nothing but degree 1, and this bracket and this brackets are equal, means base are equal, so we can write it as x square plus, when base are equal then we should add the powers which is equal to m by 2 minus 2 and plus 1 according to Inverse's law. On opening this bracket we get m minus 2 plus 3 equal to 0. B here m, and I can write this bracket here after solving. 3 minus 2 equal to 1, so we get m plus 1, and this bracket which is equal to x square plus y square plus z square whole power m by 2, difference between these two terms equal to minus 1 equal to 0. This value is not equal to 0, that is this function given, so multiplication of these value equal to 0, it is only possible this 0 or this 0. This implies that m is equal to 0 or m plus 1 is equal to 0. What we are given that here m does not equal to 0, m does not equal to 0, so only we have m plus 1 is equal to 0. On transposing 1 to right hand side we get minus 1, which is equal to value of m, which have to be find. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.